Okay, second differential equation we're going to look at. Again, let's make a note that we've got a mixture of y and x in our differential equation. So separation of variables is probably going to come into play here. We've got the particular solution through 1, 0. The last one was 0, 1. So just a little modification on that. But same kind of idea. Notice there are only 2 parts to this question. So you know that one of the parts is going to be very heavily weighted. Very rarely are they evenly weighted. Part B is finding the particular solution. So that's going to be that heavily weighted part. And just like the previous problem, it's worth 6 points. A lot of times that part's worth 6 points. So let's look at part A though. Write an equation for the line tangent to the graph. Well, guess what? That's what we had to do last time. That's a very common theme. They want you to find a tangent line to the graph at the point 1, 0. Use the tangent line to approximate f of 1.2. So we use our differential equation to give us our slope. dy over dx is equal to e to the y is 0 times 3 times 1 squared minus 6 times 1. So e to the 0 is, of course, 1. 3 times 1 squared is 3 minus 6. So that gives us a negative 3 for our slope. So writing the equation, y minus 0 is equal to negative 3 times x minus 1. Just like with the previous problem, except this time it's with the y. I don't leave that 0, okay? I am going to leave this in factored form, though, because typically it's easier to figure out. They're going to give you a decimal, but that decimal is always going to be close to that x value. So it's easier to leave it in factored form because that's going to give you a smaller number that you have to multiply by negative 3 instead of having to multiply it by negative 3 and then subtract, in this case, add 3 to it, okay? So this time, since they only have 2 parts on this question, so far we've already got 2 points. They give you 1 point for the slope at 1, 0. They give you 1 point for your tangent line equation. But again, don't forget, we're not done. It says use the tangent line to approximate f of 1.2. So f of 1.2 is equal to negative 3 times 1.2 minus 1. So 1.2 minus 1 is 0.2. Negative 3 times 0.2 is negative 0.6. So there's our approximation for that value. All right. Notice these values should typically be fairly close to each other because you're using the tangent line to approximate for an x value that is close to the point that you know is on the graph. They're not going to ask you to use that tangent line to approximate for f of 4 because who knows what happens between 1 and 4. You could have a completely different slope. Right now, the slope is negative 3. You could have a positive 4 slope by the time you get to x equals 4. So they're always going to ask you to approximate at a value close to the point that's on the function. So your approximation, in this case, your y value of your approximation should be close to the y value as well. Not super close. Sometimes it's closer than others, but it should be in the ballpark, okay? You shouldn't get negative 6. All right, that would be a huge jump for that little bitty change. All right, now to the meat of our problem. Find the particular solution to the differential equation that passes through 1, 0. So we're going to need lots of space here. Well, not tons, but it's going to take some space. Usually they'll give you an entire, if it's only 2 parts, they're going to give you an entire page to work this out. They put the problem, the problem for these free response questions is always on the left side. I know when you print them out front and back, you know, you're going to have to keep flipping it over, but they print the booklets, they put the problem on the left side, probably part A right below the problem, and then parts B and C, so that you don't have to flip back and forth. It lays right beside each other. That's just a side note about the exam. All right, so let's recopy our problem. Now, sometimes we've been getting a little careless, so let's make sure that when you recopy the problem, I would check it about 3 times before I started. I would make sure that I wrote down and copied it exactly how the problem is before I get into even trying to solve for the particular equation. Because, I mean, you don't want that to be a reason why you miss out on points. All right, so again, number one, you're going to have to separate variables. Okay, so the y's got to be over here with the dy. So if we move that, we're going to divide by e to the y, which is the same as e to the negative y. Okay, and then of course the dx, we multiply by it to get it over here on the right side. Okay, so we've separated our variables. So we get 1 point for the separation of variables, 1 point for that line right there. Now we need to integrate. So the antiderivative of e to the y, that's a great thing about exponentials. Derivatives and antiderivatives are exactly the same. You just have to remember if there's something else in the exponent that you put its reciprocal in front when you're doing antiderivatives. So that would be negative e to the negative y. Let's see here, the antiderivative of that would be x cubed minus 3x squared. Again, don't forget that plus c. You get 1 point for your antiderivatives. So 1 point for the y antiderivative, 1 point for your x antiderivative, and 1 point for your plus c. All right, now we have to use that plus c. So we've got to plug in our initial condition, which in this case was 1, 0. So the y is 0, the x is 1, whoops, minus. So e to the 0 is 1, but there was a negative in front of it. And we've got 1 minus 3 plus c. So we've got negative 1 is equal to negative 2 plus c. Add the 2. So we get 1 is our c value. So we get 1 point for using the initial condition. I would assume that it's not just using it, it's actually finding the correct c value would be my assumption. Again, I've never been a reader, but that's the way I understand it. So let's go back up here, plug in our c, and then we've got to solve for y. So step 1, we need to get rid of this negative. So we got to change all the signs. E to the negative y is equal to negative x cubed plus 3x squared minus 1. And then it's in an exponential, so to get it out of the exponential, we put it in log form. Since it was e, we use the natural log. Okay, and then we got to get rid of the negative, so we move it in front. So negative natural log of negative x cubed plus 3x, whoops, drop my squared. Always need to look out for that, is equal to y. So that is our particular solution. Remember the tip that I gave you a minute ago. Always plug in that initial condition and make sure that everything works out. So come over here to the side. Don't do it right under it, but just come over here to the side and plug in your initial condition and make sure that it works out. Plug in 1 for x, 0 for y, so that's negative 1 plus 3 minus 1. So that's 3 minus 2, which is 1. The log of any log of 1 is 0. Okay, so we're good. So we're okay there. So that is our particular solution. And we're done. 6 points. 1 point there for solving completely for y.